Welcome to Signals and Threads, in-depth conversations about every layer of the tech stack from Jane Street. I'm Ron Minsky. It's my pleasure to introduce Ian Henry. Ian is a software engineer here at Jane Street who's worked actually on a bunch of different areas, and we'll talk about that a little more in a second. I also should apologize to the listeners in that my voice is a little raw, so sorry about that, but hopefully it won't be too rough to listen to. Anyway, Ian, thanks for joining me.
Thank you, Ron.
And just to start off, can you tell me a little bit about what you did before you worked at Jane Street?
Yeah. So I joined Jane Street in 2016. And before that, the bulk of my work experience was a company called Trello, project management software. I worked on a lot of the iOS app and also the web front end. I worked a little bit on the back end too, but most of my time there was doing more front end engineering. After Trello, I worked at Warby Parker doing iOS and then came to Jane Street. And I worked on our internal exchange software, and most recently on the options desk, working on tools for traders.
That transition is a little bit of like a record scratch moment. Like started off working on front end and iOS apps, and now you're working on exchange software. Can we just talk for a little bit? How did you get here? Why did you come here? How did you find yourself in this very different corner of the tech stack?
Yeah, the thing that attracted me initially to Jane Street was the functional programming reputation. I had started doing functional programming in my spare time, both in iOS, using more functional libraries. Back in 2013, we had something called Reactive Cocoa and functional reactive programming, and it was this really big wake-up call that just made it a lot easier to build complex interactive UIs using the iOS UI kit framework. And that was just such a big productivity boost. And then my functional education continued with Clojure. There was actually this library for making music in Clojure. It was this creative coding environment called Overtone. And I'd never used Clojure before. I hadn't really used a functional programming language at all, but I was playing around with it and making music, and having a real actual programming language attached to the music software meant that I could do really dumb things like have a MIDI keyboard hooked up that I could send web requests with, or make a Slack bot that you would type a message and webhooks would cause it to play music using a synthesizer that you programmed. And the experience with Clojure, it sort of got me into this functional programming world, and I started learning Haskell because I was curious what a monad was. People kept talking about how it was this great thing that would make your programs easier to express, and I wanted to know what that meant. So I was just doing Haskell for fun, and then Jane Street was a company in New York City that was known for functional programming. I didn't actually think I could get a job at Jane Street, but I had a friend who started working here, and I feel like at the time it had this reputation for being you have to have a PhD in various things in order to work here, and I don't know.
I think that's a reputation we've had for a long time, and it's kind of never been true.
Yeah.
I have a PhD, that's true. But there's really not a lot of PhDs wandering around. If you go to the OCaml language team and the people who are doing type theory stuff, it's not everyone, but there's a fair number of PhDs kicking around there. I do think somehow our reputation has become more fearsome than it is exactly accurate.
Yeah, I feel like our public-facing image is more on the OCaml compiler type theory extreme side, and we like hiring engineers.
This is a little bit my fault, I guess. Can we go back to the music thing for a second, though? Because I've seen a lot of these tools. I am basically a musical ignoramus. And I've been to fun live coding events where people are off writing little programs to generate music. I've never experienced the music generated this way as being particularly good. And I'm curious what your experience has been in this space.
Well, again, MIDI keyboard that is sending web requests and making collaborative. I was definitely not making music, I'd say. I was enjoying sound synthesis from a theoretical standpoint, which is most of my experience with music, is the tools to make it are more interesting than actually trying to make music to me.
Amazing. Okay, so you arrived at Jane Street with experience as an iOS developer.
And you said...
We do a lot of that here.
Yeah, you should go work on this exchange software with no interfaces or UIs or anything. Yeah, it was a change of pace, but I didn't find the transition particularly... It was a good opportunity to do something different. It was my first time that I'd really thought about low latency programming in any capacity. We measure things in microseconds. Working in internet-facing companies, everything is measured in milliseconds. That was a bit of a change.
Yeah, 3 orders of magnitude right there.
Yeah. At Jane Street, the software I was working on, we would use a millisecond as sort of shorthand for something has gone horribly wrong, and it took an infinite amount of time. It's over a millisecond. We can't even measure it.
It's also maybe worth saying exchange software. What are we talking about? Jane Street doesn't run an exchange. What is this kind of software actually for?
So it's not really an exchange, but it is a program that looks like an exchange and exposes an API like an exchange to other counterparties who can come and trade with us using the same roughly protocols that they use to trade on real exchanges. But it's really a single dealer platform, which means that people can come in, they can put in orders, but they're only necessarily trading against Jane Street. They're not trading against one another. It's not an exchange in that sense. But from a software perspective, it looks like an exchange. We have an order book. We send in orders. There's a matching engine that causes trades to happen. We have software that will print the trades to a public tape after the trade occurs. It is very exchange-like.
Okay, so you did all this like weird, low latency, high performance work. Also, by the way, you came here for functional programming. That's a very imperative code base.
Yeah. But we use some fancy type system tricks to make the imperative programming very, very safe. We use the phantom type parameters in our JDTs to make sure that we're efficiently deserializing data, but we're not ever actually deserializing it. You get a little bit of that.
You still get to leverage the language. I mean, I guess a general point is people think of OCaml as a functional programming language, and it surely is that. But it's actually a really good language for imperative programming also, and a lot of the type system features that are useful in the context of functional programming work perfectly well in imperative programming, and that's a large part of what we do here as well.
Yeah. In addition to that, although most of the core of this application is this very imperative style, very low latency style, there's so much code surrounding that core tight hot loop that can be written in this very, very high level style, which is something that's so nice about using OCaml for. You can go from this very low level style to this very, very high level style in your test frameworks or something where you're not concerned about this, but you're using the same language, you're using the same types, you're doing everything in the same code base. You don't have this context switch from calling into a CFFI or something.
Yeah, this is what's nice about having what you might call a broad spectrum language, a language that can be used in lots of different styles for solving lots of different kinds of problems, but the whole thing fits together as a cohesive whole. It's just easy to plug things together, whether you're doing, as we'll talk about soon, web programming or testing systems or low latency stuff, or whether you're doing hardware synthesis. And having all of this kind of stuff fit together is really great. Okay, so now you're doing something very different again. You're no longer working on that exchange-like infrastructure. Tell me more about the spot where you are now.
So a few years ago, I started working on the options desk, specifically in a team called Trader Tools, and we make tools that Jane Street's manual traders use to understand what's going on in the option markets and then also to manipulate different things, systems, configure our automated trading systems and manual orders, various interactions. But it's mostly a data collection, visualization, and alerting and monitoring. Options are weird because there's so many of them. And a trader who is trading NVIDIA has one symbol that they're thinking about. A trader who's trading NVIDIA options has to think about hundreds of different strikes and exps at different times.
You say just what's a strike and what's an exp?
Yeah, sorry.
And actually, while we're here, what's an option?
Yeah. So options are Wikipedia, right to buy or sell something at a price by some date.
Notably at a given price.
At a given price, right. So the strike is the price that you are able to buy or sell the option before the expiration date, which is when you lose the option if you have not exercised it.
And this low-level description is maybe a little bit obscure and hard to understand. It's like, why do I want the option to buy or sell a security at a given price? One way of thinking about what's going on in the options market is, even though it's expressed through a lot of individual derivatives, things that are derived from the actual underlying, say, NVIDIA options derived from NVIDIA, there's a bunch of, it might be 100 things in what we, might call like the vol surface or this kind of collection of different securities that's parsing out different parts of the space. Really, what's the thing that you care about in this space is actually a relatively low-dimensional thing, where in some sense trading things like the volatility of a given underlying, right? How valuable is it to have the option to buy something at a given price? Depends on how likely it is for the underlying to get to that price, which is something about how much volatility, how much likely movement is there in a given security. So in some sense, it's a way of trading these deeper underlying properties of securities that go beyond just what is it trading at right now, and more about various distributional properties of how that's going to move around in the future.
Yeah, and this sort of impedance mismatch between we are thinking about these as these collection of moments, and that is the thing that we're actually trying to trade. But the way that we're doing this is trading on markets with central limit order books, and we're trying to express this opinion across the entire individual markets, which all have individual orders. And we need software that sort of helps us move from the way that we actually want to think about the options and the way that we actually trade the options in the real world.
Right. And it's maybe worth saying that this whole effort on the options desk to build a bunch of really high quality user interfaces for people is relatively new. It's only a few years old. And the options desk, like the rest of Jane Street, mostly spent its time acting as if user interfaces were not a thing. Or to the degree we had user interfaces, like they might have been in Excel or a surprising amount of Bash. went into, and probably there's still more of that bash kicking around the desk than maybe is entirely optimal.
Yeah, I think Bespoke Curses app was our main UI for a long time.
Yes, that's right.
Still is.
Right, and here Curses is like a library from the 80s for abstracting over different terminal emulators.
State-of-the-art library.
Right, and the terminal emulators were emulators for physical hardware that people used to use when using computers in the past. And that hardware has not existed for like 30 or 40 years. And here we are, still writing terminal apps through this very strange pipeline of software.
Yeah.
Okay, but we kind of changed our approach here. And even though we still have some of those Curses apps kicking around, we've now gone off and built a bunch of different user interfaces. Can you maybe sketch a little bit of like, what are the purposes of these interfaces? How are they trying to help the end users?
I think there's two broad classes, which is exploration, understanding what's going on in the markets. And these are more tools for data aggregation. We have a lot of charts or graphs of how things have moved over the course of a day. We have ways to view not just an individual option and what it is doing, but maybe an entire UND and expiration date, what's going on across all the options in that UND. We have tools for understanding this. And then the second class of application are tools for managing traders' attention, tools for alerting, tools for getting their attention and saying, hey, something interesting is happening that you probably aren't thinking about because you have a million different things that you're thinking about, like trying to get their attention, alerting them to interesting trading opportunities that we can either find automatically or that traders have said, I want to know when the following thing happens. I suspect this might happen. I want to know as soon as it does.
Right, and the trading day is busy, and part of what's going on is also about apportioning responsibility to different groups of people. The options desk is big, and there are lots of different people paying attention to different things and being able to hand off responsibility between people and groups of like, you'll pay attention to this and I'll pay attention to that. A kind of workflow aspect of it.
Routing the interesting thing is happening to the correct person is a not very technically glamorous or interesting problem, but is surprisingly hard and extremely important.
Zoomed out way too far, your previous experience working on Trello and your current experience working on tools here, like parts of that seem the same. Workflow parts and guiding people's attention to the thing that they're supposed to be watching and stuff, maybe not as real time. That's part of what tools like Trello are like. How do those two activities feel different to you? Working at this product-oriented company that's facing hundreds of thousands or millions of users versus working at Jane Street on tools where 150 is a pretty big number of people who might use the particular tool you build.
Yeah, it's very, very different in two ways. It's very different socially. We're working on tools for Jane Street traders. They're all internal, and we sit near them. We can walk over, they're on the next aisle down, we can watch them using our tools, and they can directly ask for features. We can understand what they want. We can talk about it. We can write code for them and ship it and see them use it the next day. It's not this large mass market software. We're making something that is going to be used by millions of people, and we can't directly talk to millions of people at once and see what they're looking for. So we have this immediate feedback loop, which is really great. There's also this flip side to it, which is we're not making mass market software that is going to be used by millions of people. We're making extremely niche software that's going to be used by a few really, really smart people. And the things that they want are sometimes just understanding the domain. We are not traders. We are engineers. We have to learn enough about how traders think about things and what they're trying to do in order to give them the features that they want. So it's, in some sense, easier because you can do this iterative design process to see exactly what features you want and get feedback that you have built the correct feature, and also harder because the features themselves require some amount of domain knowledge. So in addition to just implementing the feature is difficult, understanding and designing the feature is more difficult.
I imagine there's just a hard generalization problem here, right? I think you have the usual experience you have with users everywhere. If you ask people what they want, they will tell you some particular thing which is kind of related to what they want, but it's some complicated mix of what they think is easy to achieve and what they have in their head and what narrowly solves the problem that they just saw. And you have to stand back and see something broader than that and see like a simpler thing which will solve more problems. And I guess it seems hard to do that in a case where you're to some degree at an information disadvantage.
Yeah.
Where the users understand more deeply what they're doing. How do you come to grips with that question?
So something that helps a lot is people are very patient and want you to understand their problems. They're not just saying, I want this feature, go do it. You're working with the traders and you can say, okay, you need to get me on the same page as you. You're asking for this thing. I want to understand this thing. This is true generally of Jane Street. We have a lot of educational resources. You want to understand the domain well in order to do your job better. But at the same time, a huge help is we have some senior people on the desk who have been trading for a long time and also have a lot of UX intuition and ability to design. And we do lean on their experience for help as we're working on some of the features.
Another thing I wonder about in terms of like the difference between working on a consumer-facing product and working on the tools you're building here, which are essentially tools for experts, is whether that influences the way you behave down to the level of relatively small-scale UI decisions.
It absolutely does. One of the strangest things when I started working on UI tools at Jane Street is a lot of your intuition from general, what does good design look like? Everyone at Jane Street has roughly fighter pilot eyes, and they say, I want this to be about 6 pixels high because then I can fit more of it on my screen. And you're designing these tools with extremely high information density. If you try to do something like that for a general product company, you'd be like, this is unreadable, this is unusable. Traders don't ever want to touch their mouse. Everything is accessible from the keyboard, which is a good additional feature to have, but there's a lot of discoverability problems that comes from that. You can't hover to see more, to see interactions, because you don't have a mouse to hover with, because you're trained on using Curses apps for your whole career.
And it's not just you're trained on it, like it's actually better, right? It is just a higher bandwidth input mechanism to be able to like quickly smash things out with your fingers than it is to move the mouse and click on a thing. It's just dramatically different.
Yeah, not that we don't have tools with mouse interactions, but the information density is a big difference. And we don't spend as much time on things like discoverability of features. It is important, but ultimately your users are kind of expert users who know these tools and live in these tools and use them all the time. So we don't have tutorials necessarily. We have vaguely written help documents and getting started, and then the people around you teach you how to use the tools to the expert level that you have to.
Right. Although I have seen nice features come in. One of the great things you can have in a web UI as opposed to a terminal app is you can have tooltips. And that's pretty good. And you can have links to web pages, so you can have things that show up and then you could click a link and it can show up on the appropriate page on our wiki where someone can go in and, in fact, if the documentation isn't good, you can just crowdsource and dive in and go and modify it. And I've seen some of those things kind of pop up in the apps that you guys are building. As the firm grows and there are more people using these applications, it does become more sensible to lean more in the direction of having the tool teach you what to do and incrementally less have just the people around you always teach you how to use it.
It's absolutely true. It's an evolving process.
So we just talked a bunch about how the goals are different and the things you're building and the shape of the designs you come up with. How about just the process of writing code here? How does that differ from things you've experienced in the past?
So writing internal software, there are so many things that we would spend time on making broad market, internet distributed software that we just don't have to think about at all. So when we're writing code at Jane Street, we're almost always thinking about the specific application and the application logic, and we spend so much less time thinking about these ancillary things that we used to spend time on at Trello, for example. And these are just things like having accounts and logging in and signing up and forgetting your password, or processing payments, or distributing resources over the internet, because everything is internal and we have these very fast internet connections. We can just download 5 megabytes of JavaScript and never have to think about it. So we can focus much more on the core application logic that we're working on. And this may be unexpected good and bad thing, which is it's very easy to spin up new applications, as opposed to this is the Jane Street app, and we're all working on the Jane Street app. We actually have tons of web apps, and if you're working on a new feature, maybe you're going to start a brand new app from scratch and deploy it, because all of these surrounding infrastructure of setting up your CDN and configuring domains and all of this is roughly free. And the work that you're doing is just working on the application. I think another thing that I like about working at Jane Street is we don't have just NPM update dependency, constant treadmill of keeping up to date with all of the external libraries that you're using. Something that took a surprising amount of my time in a past life.
Right. I mean, there's a little bit of some good and bad in that. Part of what's going on is Jane Street has, to a kind of weird degree, been on its own parallel universe software adventure for the last 20 years. Where it's built lots of custom stuff and it doesn't hook into the outside ecosystem as much as you might expect. There are like real compromises with this on the JavaScript side. There are lots of cases where we've brought in useful third-party libraries and wrapped them up. But we definitely don't do this whole like, bring in whatever packages like NPM decided to bring in. It's kind of problematic from a stability perspective. It's also kind of a security nightmare. So anyway, there are lots of reasons why we want more control over the ecosystem than that.
Yeah.
Another thing that we've talked about in the past that seems pretty different is And then I've kind of noticed myself in my own working, just at the level of file formats and protocols and whatever, there's ways in which we just use different sets of things.
Yeah, so at a very high level, you're focusing on the application. And then the application that you're writing, everything is written in OCaml, the client, the backend, and the front end. And most Jane Street engineers who are working on these tools are really working on full stack, backend, and front end. And there's very, very blurred lines between the two. Not only blurred lines in the code base sharing types, but as you said, we have automatic serializers that generate stable protocols between the client and the server, such that if you have a value on the server, it's roughly one line of code to have the value on the client. You sort of get that for free. So you're not spending a lot of time building your JSON API v1, v2, and then writing the parser on the client that consumes them and creates these mirror image types that are hopefully compatible with what your backend types represent. We really just have the same types and the same logic. This is really powerful. We can do things like offload computation from the server to the client to sort of parallelize something across all of the users who are doing something, and we can just run the same code.
Oh, that's interesting. You can move it from the server to the client to parallelize it.
Yeah.
And you can also move it from the client to the server to make it faster and parallelize it, depending on how you have your resources distributed.
Yeah.
Nice. Another point on this, which has always struck me, is just the degree to which we don't use HTTP for everything.
It's kind of like this historical thing where we've had OCaml RPCs and client-server communication all the time. And when we stuck it in the browser, we just sort of tried to move our existing OCaml ecosystem into the browser pretty closely. So you're immediately able to use all of the existing servers and talk to them the way that you want to. And we don't use HTTP, we don't use REST, we don't use any of these traditional GraphQL, like anything that you would see in the outside world. Instead, we have bespoke generated OCaml protocols that work over these pre-existing live update streaming RPC things that we have built. When you're talking to your server, you open a WebSocket connection, and you speak this language, and everything happens over this channel. If we ever wanted to make software for the outside world, and we suddenly had to support the conventions that people are used to and expose JSON RPCs, I think we'd be at a pretty big disadvantage. But not having to think about those things internally and getting all of that for free within the tools that we're writing, it's a huge accelerator for adding a new feature. I want to add this new piece of data. You add it to the record type, you populate it, you're kind of done. There's no more type bumping or anything. We do have to think a lot about stability as we upgrade, and clients are running different versions of the server. And for the most part, we own the users, we own their browsers, so we can just force them to refresh when they need to pick up a newer version.
Yeah, and there's a certain amount of joy of not having to think about versioning. We care about versioning in lots of places. It's complicated and messy, but the cases where you can just not worry about it are glorious. Yeah. A thing that's in some ways I think of as weirder about the outside world than about us, which is that HTTP has become synonymous with network connection.
Yeah.
There's this thing underneath called TCP, which you might have heard of, which actually, for a lot of the things that people use HTTP, you could totally use TCP. It works fine, somewhat lower overhead. You have more freedom. There are other ports. Turns out it's not all on port 80. There are other ports that you can use and other protocols. And somehow the outside world has forgotten all of that and been like, no. There's HTTP and HTTPS. And actually, there's just HTTPS. Yep. Everything should go over that. And that's just not the way our ecosystem is shaped at all. Because there are custom protocols that we build. There are lots of things that are just kind of rawly on top of TCP/IP.
Also TCP, you're getting high level already. We built our exchange protocols. This is all UDP multicast. We don't have this TCP thing.
That's right, too fancy.
Yeah.
So another way in which the programming ecosystem, specifically on the front end side, is different is not to break out of the usual Jane Street doing our own different thing. We have built our own frameworks for building web UIs. This is a framework called Bonsai. And I'm kind of curious how you think of that as changing the experience of building user interfaces here.
Yeah. So because we're writing OCaml, we sort of had this question of, okay, we want to use OCaml to build UIs. What do? UI framework-wise. Building UIs is pretty complicated. Managing state is pretty complicated. Manipulating the DOM is kind of fraught.
And just to say, there's a weird fact about the world that you talk to kids out of school from fancy undergraduate institutions and they're like, UI stuff. I don't ever want to do that UI stuff. And at the same time, it's actually one of the richest, most complicated, most interesting programming problems you'll ever run into. And it's actually really hard to do well. So there's an odd mismatch where it doesn't get a lot of respect, and yet it's obviously important. Building user interfaces that are good matters to people. And it's really challenging and interesting.
Yeah, it's really difficult. And you end up thinking about so many different pieces of state and ongoing especially if you're building something that is interactive or building something like drag and drop, modeling these interactions as explicit data types in ways that are both accurate and robust, it's all pretty difficult. I think part of the reputation comes from a lot of front-end work is also working around browser differences and incompatibilities, learning how to do CSS layout that works in different versions of Edge or something. And we are fortunate to be able to ignore a lot of the things that make front-end development less pleasant and really just focus on the interesting, difficult parts of it.
Right, we do not support all the browsers in the world.
Yeah.
Just the browser we like.
One version of Chrome, and everyone's on the same version. So that makes it, I think, not to undercut your point of the general front-end reputation is low, but yeah, it is bizarre. I think building UIs is incredibly hard, and there's so many different approaches, and it kind of seems like no one has exactly nailed it. And it is the reason there are so many different UI frameworks out there is that it's a very difficult problem and no one's really cracked it. So of course we built our own to try to crack it instead of trying to write OCaml bindings to an off-the-shelf library. And we use Bonsai. A lot of what makes writing front-end code at Jane Street feel very different is that we're writing it in OCaml. Not only this type-sharing, isomorphic server-client, easy protocol connection stuff that I was talking about before, but also just we have types. We have really, really good types. We have some types, which are really valuable for modeling a lot of the state that you have in a front-end application where you might have a value on the client that you want to sync to the server, but it has not been synced yet, and the server thinks that the value is this thing, and you can build this composite complex type and wrap all of your types around it and have a interaction monad. I've used SumType several times.
I was just about to say, what is a SumType and why does it matter here?
So many programming languages give you a way to say, I have this and that and that. And more, increasingly, languages are giving you now a way to say, I have this or that or that. And I think Rust has this as a big mainstream language that has algebraic data types for the sum, or, and product, and, which is just, a fancy word for a very intuitive idea. But in OCaml, you can express something like, I have got this result from the server, or I am still loading this result, or I got an error from the server, and this is a sum type. It just means that I have this or that or that. And a lot of the just basic types that you're thinking about when you're writing front ends benefit immensely from being able to say just exactly that. I want to load this thing, and then if I get a response, I want to load this next thing. And expressing that as soon as I get an error, I want that to propagate through the whole chain. And you can make a monad to do this, and it makes it easier.
The monadic thing is for chaining some of this error handling together in a nice way. The basic underlying property of these disjunctions, these sum types, is that they let you say this or that or the other in a clear way. And then maybe most importantly, there's a good language facility for doing the case analysis. There's this thing called a pattern match, where it lets you make sure that you are exhaustively considering all the cases. And it turns out in just an enormous amount of programming is case analysis. And having tools that help you do the case analysis and make sure you did the case analysis correctly, exhaustively, making sure that you don't mix cases from different things, that you're actually looking at the thing that you should be looking at. It's just incredibly useful and comes up all the time. And it's kind of shocking that more languages don't have it. You say it's increasingly there's more of it. It's sort of, in the same way that Rust is sort of a mainstream language. It's just barely in the top 20 or something. But actually, the vast majority of languages don't have any good support for this. And it really is kind of a crying shame. The idea that one would generate a new language past the year 2000 without adding some types just seems like a disaster.
You kind of forget when you work at Jane Street for a long time. How do you write software without this? So a little bit spoiled there, but especially on the front end, I don't just have this string. I have this string that is embellished in some complicated way. And in order to actually display that to the user, I need to think about, well, what if it failed to load? What do I do? And depending on the tools you're using, it can be easy to forget about that. And OCaml makes you think about that every time. The type system reminds you, anytime you want to use a value, well, what if you failed to load that? What do you want to do then?
Right, so there's a fundamental trade-off here about explicitness. Part of what the type system is doing is just forcing you to explicitly consider various cases. This goes back to another difference in the languages. Many languages have some kind of null pointer or a null value as an implicit part of every value. So you have a type system that tells you what's going on, but it doesn't let you distinguish when you do and don't have null. And you just have to think about it carefully on your own and make sure you get it right. And it's all just kind of implicit in the code. And in a language like OCaml, this kind of analysis is explicitly forced for you to think about. Okay, so that's some ways in which OCaml makes the process of writing things different here. How about Bonsai itself? Are there interesting aspects of the design of that library that affect what it's like to work in?
Yes. So Bonsai is actually pretty familiar if you're used to something like React. It is a library that uses VDOM patching, diffing, and patching. But unlike React, where you have this component tree, Bonsai is sort of this pure functional core of, okay, what if we built a library for expressing incremental state machines with internal state at any levels of this complex computation graph? And then you put virtual DOM nodes as some of the values in that computation graph, and you hook up a machinery to apply virtual DOM patching to a browser. The description that I just gave is like this weird functional programming nightmare. But what it actually amounts to is React, but principled, where instead of having like your implicit component tree, which can sort of magically implicitly contain local state through something called hooks, instead you're just very explicit about, okay, a component is a value that can change over time. We have this VDOM structure and it can change over time. We have these other things over here that are strings and ints, and they can change over time. And we can produce UIs that are pure functions of those strings and ints.
Right. And so the things I'm hearing you saying is one difference is that you have a more general computation model, right? The React stuff is in some sense specialized to computing a tree of DOM nodes. And Bonsai gives you a system for computing any computation that you want. And then we happen to use it for computing some DOM nodes or virtual DOM nodes.
I think that we did set out to write a good front-end framework. It's just that it turns out that a good way to solve the front-end framework is to solve this more general, higher-level problem.
Yeah, and I think part of the motivation there had to do with actually some of the performance-driven issues, right? I think one of the things that makes building UIs in a trading environment different is you have this constantly changing stream of data that's coming in that changes what you need to display to users. And so there's all sorts of incremental computations that you want to do efficiently, where you're just reacting to the new data and not having to refresh everything. And React has a lot of work to let you not have to refresh the entire page. But here, there's also a complex computation where you're like merging and combining and transforming data. And you also don't want to redo all of that. And so I think part of what drove us in a more general direction was the desire to be able to optimize more deeply the computations that were going into what you were displaying in the UI.
Yeah, and then you can also use that same mechanism by which you can express this computation graph at whatever level of granularity you want to break up your UI into whatever level of granularity you want. You're not necessarily limited by like, okay, this component is going to re-render when its internal state changes, and it contains these subcomponents. You can say, okay, I have a single logical component, like I have a single function, and it contains these two pieces of UI. I'm not going to re-render the whole thing whenever any of my state changes. Instead, this piece, this particular bit of virtual DOM, is a function of these inputs. This other piece is a function of these other inputs, and you can choose how granular you want to go with that to really control your re-rendering and get better VDOM diffing behavior, even as lots and lots of things are changing all the time.
Right. So it's a more general system that gives us some extra powers in performance space. We can optimize things better. It also gives us some extra ability to break things down into meaningful components that are easy to think about independently that aren't necessarily just computing chunks of VDOM. So that's one difference. What are the other differences that you see?
Another big difference is this explicitness. I'm contrasting this to React because I think that a lot of people know React, but I am not really one of them. The last time I used React professionally was more than 10 years ago, and I'm out of date. Now there are hooks, and I only have a layman's understanding of this. So a lot of the things that I'm going to say about React are going to be probably wrong in subtle ways, and people can hopefully not discount everything that I'm saying based on that. But React does a lot to give you this apparently simple API. When you're writing a component and using hooks, there's really this very complicated reconciliation process happening under the hood in order to associate the state with the correct component as you're re-rendering things. That amounts to, I can create a state hook that contains a string, but I just have a string when I'm writing my code. But you're sort of limited in what you are allowed to do with that string. You can't conditionally inspect the string and then decide to create some other amount of state based on the value of the string. There are various ways that you can like illegally write a React component if you're conditionally creating a hook or calling something a variable number of times between component invocations. And these are things that linters can catch for you, and there are rules that you have to follow in order to use React correctly. And you know the rules, and they're not super onerous, but there are certain refactors that have the possibility to introduce bugs. Bonsai sort of does not try to do any of this implicit magic, sort of make it look like you're creating this just regular variables that you can just use like they're variables. Instead, it uses OCaml's type system to really enforce this separation of, okay, you have a bit of state that's changing over time. Well, that is sort of like a promise, essentially. It's something that you can't just look at it. You can't just put that value into some DOM node. You have to construct a new computation that explicitly takes that as an input and produces an output. We have very good notation for expressing, like, I have an input of these 5 computations. It's not quite as annoying as use memo and listing out every single input, but you do have to be explicit at the level of this particular computation as these particular inputs. We use OCaml's type system to ensure that, like, you can't forget to do this. If you did not explicitly register an input, you just can't use it on the other side. You're just going to get a type error. So although there are things that you could write that would be wrong, the compiler will check them for you immediately. And you get this immediate feedback that, like, oh, you have done this thing that is illegal.
This sounds to me a little bit like the trade-off between C++ and Rust, which is in C++, or C for that matter, there's a bunch of things you have to do quite carefully when you're writing code. There's all these disciplines around when code is created and freed and shared and modified, and how you are supposed to handle pointers that are to values that are on the stack and all of that. And there's nothing explicitly forcing you to do it. You just have to get it right. And when you don't get it right, you're in crazy undefined behavior land, and you're going to have a bad time, and things are now kind of hard to debug. And in Rust, there's a much more explicit system for tracking this. You essentially have guarantees that you're getting it right. And the trade-off there is there's a bunch of extra complexity. There's like a fancy type system that you have to wrestle with. And there's just more typing, more characters are required, because you have to be explicit about, like, what is their discipline for managing memory between these two parts of the code, and, like, what's the contract between them. You actually have to write that contract down rather than just hoping that people roughly infer what it is because they kind of know the style of how this particular piece of code is written. How well do you think that maps onto what you see in the kind of Bonsai versus React case?
So the explicitness is definitely there. You're definitely typing more characters when you're using Bonsai than when you're using React. But I think an important difference, and I wouldn't want people to get the wrong idea, is there are certain things that are actually just harder to do in Rust. And they might be perfectly safe things. Like, I want to create a doubly linked list in Rust, and I want to do that safely using the borrow checker. It's like, I don't know how to do that. That's fundamentally very difficult to do in Rust. And
I think it's not difficult. I think it's impossible.
Okay.
You literally cannot create a doubly linked list, because it violates the core constraints of safe Rust. And so you need to, like, go off and use some of the extensions or explicitly use the unsafe extensions of Rust. So it's like, it's doable, but it is not trivial.
I don't want people to think that we're paying such a high cost. Everything that you can do in Bonsai, you can express exactly what you would be doing in React. There's nothing that is sort of forbidden or off limits. It's just that it all has to be extremely explicit. But you can model all of the state. But for example, in React, a mistake you can make is you can render a list of components without giving them an explicit key. And it'll warn you, and it's not like it's impossible to write React code correctly.
It's also not impossible to write C code directly. We have Valgrind, we have lint, all sorts of linters and stuff.
Yeah, that's fair.
It's very similar in some ways.
The only way to render a dynamic number of components forces you to provide a key in order to do that. So it's not as difficult. The rules are more directly mapping from the rules that you are already following to write correct React code. We just have a type system for it.
Let's leave the world of code for a second. I want to pop back to trading for a bit. So we were talking before about the difficulty of dealing with the kind of information imbalance of, like, you know a lot about software engineering that the traders don't know about. They know a lot about what they are trying to do that you don't know about. I imagine some of the process for you has been learning more about it. How has that gone? Like, what has the process been like for you of coming to understand a little bit more? Like, options is an especially complicated domain in the trading world, I think, for a variety of, down to, like, even understanding symbology. What security am I trading? What does it mean? Is a surprisingly complicated affair. And I'm curious, how has it been coming to grips with everything from how we think about modeling options prices to the details of the technology? What's that process been like for you?
It's very humbling, I would say. It's definitely shows that I would not make a good trader, and I'm better suited to stay an engineer. We have really good internal education for, I think this is true for all desks and all specific domains that people have to understand at Jane Street. But there is a lot of education, a lot of explicit learning. The tools that we work on are very broad. And I feel like at times I have to understand a lot of different areas of options trading at a sufficient level that I can program it, but we don't go extremely deep into any particular small aspect of options as a domain. And we have more specialized teams on the desk, people who work on pricing, people who work on computing options fares or finding implied volatility from the markets, and they go very deep into these more narrow domains and like really understand this. I wish that I did a little bit more of this, to be honest. I feel like building the tools for understanding all of options trading at once requires some amount of like, okay, we have this piece of the domain. I have to understand that well enough, but that is like one of the 40 different things that we're trying to present to traders. So it is a little bit of, I don't know, I definitely don't feel like I could come out of this and become an options trader. Instead, have this very broad picture of all of the different pieces that fit together. But if you ask me to compute early exercise decisions, I'd be like, okay, hang on. I need to like go work out the math for a little bit because it's not something that I've done. So education is very good, but the tools specific team is at this weird... You
have to know a little bit of everything.
A little bit of everything. And it's difficult and it's humbling. There's a lot of things to learn.
In this kind of environment, what is it like actually improving something? Can you give me an example of like a problem that you've run into of something where like the tools aren't doing quite the right thing and you need to work with people and with the traders and try and make things better? Can we make it a little bit more concrete what one of these efforts might look like?
So something that I worked on recently is we have a type of alerting of an interesting thing is happening in the market. We want to tell traders. And there's this frequent tension between we don't want traders to miss an interesting thing, but we also don't want to annoy them with constant, this thing is happening, and they're like, all right, come on, like, I don't care. So balancing noisiness and building more complicated rules for whether something actually is important, and then maybe stateful, interesting things where conditional on the fact that I have already told someone about this, how much less do I want to tell them about the next time this happens? And we have time-based rules for don't alert on this too frequently or increase the threshold by which, it's moved this amount. It needs to move more in order for us to tell people again. So a common type of improvement is I'm hearing this alert too much and I would like to hear it less. So all of the things we do are very full stack. So it'll start with, okay, we need some new piece of data to say, evaluate the interestingness of a certain opportunity. And that requires learning various things about the market or how much it usually trades in order to say that this is more interesting than usual. And then ultimately, we're going to do our best and build these heuristics and talk to traders, and they're going to try it out and say like, yeah, this seems better. I'm not annoyed as much as I was before. But then we often have these thresholds or configurations. We want traders to be able to, ultimately, they know how often they want to hear about things and they want to be able to configure these things. So Jane Street has internally a lot of trader configurable things, and we leverage existing infrastructure that we have for traders to go in and tweak values, tweak parameters, edit things about how often they want to hear certain alerts.
Yeah, so there's two problems I see you talking about here. One is there's a general kind of alerting the appropriate amount problem, like alert fatigue. It's kind of a fundamental issue. And actually, I think a problem I imagine you run into, because I feel like it's a problem we see everywhere with traders, is they under-complain about this issue. Yeah. I think they are subject to alert fatigue. But also, Jane Street traders just are socialized to have high pain thresholds. If every day you need to like come in and pick up a hammer and hit yourself on the head 3 times and then like slap your hand on the desk in order to like turn the crank and make the money, people will just do that over and over. But in the end, it's actually not good for them and their efficacy and their happiness. And so there's an issue of actually, you kind of want to overreact to people's concerns in this space. So that's like one problem. And then one way you can deal with that problem is you can give them dials. It's like, oh, I'll give you some configurations and you can modify it. And then you can push things back. And now you have another problem.
Yeah, and we don't want to off-source all of this work to traders and be like, all right, it's your problem now. We do want to get it as close as possible, but things happen, things change. We want to be able to react to, okay, whoa. Because things are so busy today, the typical thresholds that we've set are not working well. So I want some way to tweak that intraday. And that's more why we give configurable knobs rather than just, okay, it's your problem. You have to go figure out what the threshold should be.
So do you end up taking lots of different kinds of data and situations and conditions and then packing them all into one interestingness number, or are there many different notions of interestingness that float around inside of the system?
For some systems, we do. For systems that are looking at lots of different types of interesting events and who want to surface those and decide which of those to surface, we have metrics for roughly sorting them by interestingness, sorting them by value, by how valuable we think telling a trader about this is. And then we have sort of global thresholds that we can set for, okay, because today is so interesting, I want to hear half as many alerts. I want to double the interestingness metric, the threshold by which you're going to actually play sounds on my computer. I just want to take this up, or I want to take this up for this particular asset class today. So we have these knobs, and often the thresholds get sort of tuned stably over time, and then we just sort of relatively change them to respond to changes in the market or changes in busyness.
How do you avoid ending up with just an unbounded amount of configuration that persists over lots of different people when new trader is hired and they start, it's why is everything terrible? Oh, it's because you have all the wrong knobs set. How do you make it so that the default experience of a new person is actually good when you give people the ability to adjust and tweak the system to match their needs?
Yeah, we've gotten better at this over time, and that is making fewer per user knobs and more desk-wide knobs. So if you particularly want to hear less about this thing, probably that means the entire desk wants to hear less about that thing. After having built too many bespoke configurable things such that the people sitting next to each other using these tools are using completely different tools, we try our best to unify these and give desk-wide configuration more than user-specific configuration.
Some of the, again, maybe different from what you might see in some consumer products, well, or maybe the same, but there's some amount of trying to make a better experience by constraining what people can do, by taking away various kinds of choice, which I guess actually has totally happened in consumer stuff. I remember in the good old days when you used Winamp or something, you could have all the UIs, any UI you wanted, right? And now the world has settled on you have one bit. You could be in light mode or dark mode, and that's it. And everything else is going to be managed centrally. So we've talked a bunch about the stuff you've done here. You also have done a bunch of interesting personal projects over the years. I think one I've personally enjoyed watching a lot is a thing called Bauble. Can you maybe say a few words about what Bauble is?
Yeah. So Bauble is sort of a live coding environment. It is a website you can go to and type a few lines of code, and you will get 3D images and animations from that code. And if you've heard of shaders or shader toy, it's a very similar idea where you're writing a program, it gets compiled to an OpenGL shader, which is essentially a function that runs on every pixel in an image and says, what color should this pixel be? And you can write very interesting functions that say, okay, depending on the position in the image, I'm going to maybe do ray marching, I'm going to do ray casting to compute the color. And you can do surprisingly complicated and intricate images just in this pure function from pixel to color.
Should I think of this as roughly a thing that has been designed to run efficiently on modern GPUs so that you can do it really fast and at real time and get high responsiveness?
Doing chunks of pixels in parallel such that it happens very quickly. And you can do some really incredible real-time rendering, and a lot of people have. If you look at Shader Toy or the work of Inigo Quiles, it's really impressive how much you can get the GPU to do. But doing that requires writing this kind of low-level language called GLSL, the OpenGL shader language, and then compiling it using WebGL and rendering it. It's very low level, which you'd expect for programming a GPU, but I wanted something extremely, extremely high level. I wanted to be able to say, okay, I have a sphere, and I want to union that with a cube, and then I want a 3D rendered version of this thing that I've just expressed. So Bauble is a tool that gives you this very, very high-level expression-oriented functional language that it will then, you use it to express 3D shapes, and then it compiles down to hundreds of lines long shader that will do the ray tracing for you. And it's based around signed distance functions, which are this really exciting and really interesting way of modeling 3D space as pure functions.
Let's talk about this more. So what is a signed distance function, and why is it interesting, and why is it different from the way that this is not the only programmatic system for building 3D designs? There are plenty of others out there, but the signed distance function is not something that all of them do. So what's the point of that as an abstraction here?
Yeah, so a signed distance function is literally a function that takes a point in 3D space and returns a float. And what that means is, what is the distance from this point in space to the nearest point on a surface? So for example, if you have a sphere, the distance function is very easy. It's an easy function to write. You take the distance between the point you're asking and the center of the sphere and subtract the sphere's radius, and that's it. That's the function. The interesting thing about them is that you can compose them. So given two signed distance functions. You can call them with the same point. They'll give you two different values for the distance. And then you could average those two values together. And now you have a new shape, which is if you had a sphere and a box, now you have something that's kind of halfway in between the two. Or you could average them only when they're very close together in value. So the sort of edges of the surface, the boundaries blend smoothly together. And you can build a lot of interesting shapes using these just function composition, just calling two functions, doing something interesting with the value, or doing something interesting with the input to the function. And you can use this to express like crazy, interesting transformations in 3D space. Like I have a cube and now I want a twisted cube. You can just do that by manipulating the input coordinate that you evaluate the cube with at every point. It sounds very abstract, but it is.
But it actually gives you something, right? It gives you like a richer kind of composability to make it easier to take different things and actually smash them together in ways that make sense and in a way where you can have somewhat predictable visual outcomes of the operations that you're doing.
To contrast this with traditional 3D modeling, you have points, you have triangles. It's kind of hard to do the thing that I just described. If I have two shapes and I want to like smoothly blend them together. Well, okay, I have to like compute the surfaces of those points and add a bunch of additional points in order to express the curvature because everything has to be a triangle. And you sort of have this very different representation that can do operations that are hard to do if you were doing it on a 3D mesh.
But the other thing that's weird about where you triangularize everything or you just turn these into polygons is you have to kind of in advance decide what is the granularity at which you want to combine things and then do the operations for joining things together, which first of all can lead to weird artifacts, right? Where it's like, I create a sphere over here and a square over there or a cube over there. The sphere has it's not really a sphere. It's now some weird triangulated shape. And then the edge where the two things merge is going to have weird zigzag pieces because of where the two grids now interact.
It is this idealized idea of a sphere. It is this pure function that represents a sphere. And if you actually wanted to 3D print that, you could materialize that function into a triangle mesh if you wanted to export it to another program or do something else with it. But as you're writing your program to produce these 3D shapes, you just think of it as this pure function. It is an infinite resolution sphere, and I can do anything with it and compose it with anything else, and I get things.
Right. In some sense, you step away with these triangulation tools from the infinite resolution thing very early. And in this kind of systems, you step away late.
Yeah.
Actually, you talked about these signed distance functions where you can now compose things together. I think you were lying to me because you said they were signed distance functions. And I think I don't believe you, which is to say, I think I can write the signed distance function for a sphere. And I think I could maybe write the signed distance function for a cube. But that swizzling operation you described that takes something and like transforms it together. I feel like the thing you have at the end probably is not literally a signed distance function anymore.
Ron, yes. That is exactly right. And I probably shouldn't call these signed distance functions, but if you want to research or learn more, that is the literature that will describe these. But they are no longer signed distance functions as soon as you start performing certain transformations to them. There are ways to compose signed distance functions and get a perfect distance function as a result, but a lot of the really fun parts of it sort of violate this invariant, and you end up with approximations of a distance function.
A signed distance-ish function.
Yeah, it's like a signed proximity function, maybe. The neat thing is that you can compose these, but there is another really important aspect of this, which is that you can ray trace them efficiently. It's called ray marching when you do it to a signed distance function, because you can say, okay, I am looking at this point in space. How close is the nearest shape? And you ask your signed distance function, and it says, you got like 60 units. And then you can just jump ahead 60 units because you know that is the nearest shape. You don't necessarily know if it's in this direction, but you know that in every possible direction you could travel, space is empty up to a distance of 60. So you can ray trace these in a very, very few number of steps, which is what makes you able to write real-time animations that run on your GPU at high resolution of like, you're not literally ray tracing it. You're doing this using the distance function information in order to skip parts of space. When you don't have a perfect signed distance function, you can do things like skip past it or jump into the middle of a shape because the approximation at this point is not the same as the approximation when I actually jump forward. So these are things that you have to think about if you're using signed distance functions to make art and animations. And there's various mitigations that you can use to make evaluation slower, but at the same time, it's more fun to play with these bizarre, not quite distance-safe shapes that you've constructed.
So the ones that violate the rules are fun in their own right because they create weird visual artifacts when you render them and have strange behaviors all their own.
Yeah, or like, I want to take this 3D shape and extrude it along a Bezier curve. that produces something that is, it's so close to a signed distance function that you can still get a good-looking image out of it. But if you then want to use that as the input to another operation, now you're kind of in trouble because you started with an approximation, then you did some math to it, now you have like a really bad approximation. So there's a lot of these rules and things that you learn as you play around with these shapes.
So if you go to bauble.studio, and I encourage people who are listening to go to bauble.studio, one thing you will immediately notice is it's way too nice. It's like a really fun, really pleasantly designed little app. You get to, on the left-hand side of the screen, write a little program in literally your Ian's favorite dialect of Lisp that describes the image there. And I just wonder, how did you find the time to do this kind of project? It seems like really quite an investment.
I think part of the fun of signed distance functions is that they're way easier than they look. It's so easy to write this sort of ray marcher. People have been doing this a lot, and they've learned how to do this. So I am, in some sense, just packaging up a lot of different things that other smart people have already figured out into a single tool. It uses Code Mirror, which gives you this very polished environment when I have a small amount of code to generate autocomplete and stuff, but mostly that's just Code Mirror, and Code Mirror is really good. So it looks polished. And you can produce some pretty good-looking 3D renders, but I learned how to do all of this from watching what Inigo Quiles is doing and using a lot of his primitive functions that he's already figured out and a lot of the methods that are used by other people on ShaderToy. So I think it's actually looks a lot more impressive than it really is. I spent a lot of time building this high-level compiler, and there's some bits of it that are more bespoke things that I wanted, like you can interactively edit numbers in the code editor, because it's kind of hard to create a 3D image just by typing in numbers. If you're writing a color, it's nice to just be able to drag and drop things, or if you're positioning things, you can just drag vector literals around the screen. And
oh, right. There's a thing where you go to a number and click on it and drag to the right or the left and have the number interactively move. And then also the image interactively changes as you do that. So you can kind of try and pick the number that actually looks right in a nice way.
Yeah, so there's some amount of bespoke work that went into that. But yeah, it took a long time. I don't know.
How long did the project actually take?
It's hard to say exactly. I think I've probably worked on it seriously for around 5 months. It's been my main side project total. Hard to say. I worked on a lot of it while I was on parental leave. So that is where I found the time, was during naps. But I don't have nearly as much time to improve it since.
Right, and now you have a kid who probably naps less.
Yep.
So you've also done a bunch of fun physical projects. Maybe you could tell us a little bit about some of those?
Sure. So a recent one is adding 3D mesh export to Bauble so I can do 3D printing. That's been kind of fun, getting a little bit into that. I've built some musical instruments. That's something that I don't really play any musical instruments, but it's surprisingly easy to solder together a microcontroller to a bunch of buttons and then program it to do interesting MIDI things. I built a mechanical keyboard, and it's shockingly easy to do. And I was like, okay, I can design and build bespoke MIDI instruments now, just using a lot of the same techniques. And that's one of my hobbies.
Do you ever play them and make music with them, or is it purely just
ridiculous, Ron? I try to get my baby to play them, but he is so far not taken to them.
You also made a corded keyboard.
One of my MIDI keyboards was this experimental corded input mechanism where holding down different sets of keys would give you different notes in a stable way that, I don't know, it was an interesting experiment that doesn't really have a physical analog. Part of the fun of making electronic instruments is you're not constrained by I need to put holes on a tube somewhere to get the right frequencies. You can do all these weird things and have instruments that move relative to one another. This button just goes up by a semitone rather than having absolute pitch. There's a lot of freedom and fun design space to explore building custom instruments.
And then never performing with them.
Yeah, it's fun to build them. It's also, ask me how many things I've made in Bauble. It's much more fun to build Bauble than to actually make art with it.
Although I've seen some of them, they're pretty cute. Another fun aspect of Bauble itself is you ended up using this somewhat obscure Lisp variant called Janet as the programming language for Bauble. And I'm curious what got you there. Why did you end up using this? I feel I often describe OCaml as comically obscure, but I think Janet is even more comically obscure than OCaml.
Extremely obscure, yeah. It seemed obvious, and I can't justify this, but it seemed obvious that the way that you should express 3D shapes in a programming language would be some kind of Lisp.
That's a very hipster opinion.
Just the notational, like, I wanted something extremely concise, and I wanted things like variadic functions. I don't know, in contrast to OCaml. OCaml is a little bit verbose, and I like that for building a real application, but I wanted something where I could build a very concise notation for expressing different combinations. So it clearly seemed like S expressions were a good way to do this.
Right. For those who are like not Lisp aficionados, just a really unpleasant number of parentheses. Every single thing is parenthesized. That's in some sense almost the only syntax affordances, like paren, function, arguments, close paren, and everything just kind of builds off of that.
Bauble actually has a lot of Lisp blasphemy built into it to give you sort of postfix function application and also infix functions.
Oh yeah, you're not supposed to do that in Lisp.
You're not supposed to do that, but it is very, very nice for expressing GLSL languages. I wanted some amount of notational freedom also because GLSL, despite being like relatively low level, has surprisingly nice notational affordances for manipulating vectors. So something that you can do in GLSL is if you have a three-dimensional vector, you can write vec.xxy, and you get a new vector that's the first component and the first component again, and then the second component. And there's this neat, concise swizzling operations that you can do, and also various operations that are overloaded to like do the right thing on vectors. And that's all very nice. I didn't want to lose that notational concision even as I added more notational concision. So the language that Bauble uses is really modified Janet with some custom macros for it makes it a little bit easier to type sequentially without having to go and wrap your parents and keep them balanced.
Right. And I guess that's like the other thing that makes Lisps different is they have really good macro systems.
Yeah, the fact that I could get this level of control over, I really want the program to look exactly like this. I can get that syntax without having to write my own parser, without having to do that. That was an appealing aspect of it.
And then you wrote a book about Janet. How did that happen?
So I had so much fun building Bauble, in part because I wanted to use Janet because Janet can very easily compile to WebAssembly. And I don't know, I thought it would be more fun to do the whole compiler in the language that you use to express the language, as opposed to parse this notation and then execute it in JavaScript or in OCaml or something else. So really all of Bauble and its compiler are written in Janet. I thought this was really fun to write this web app that is not heavily JavaScript. And embedding Janet in the web was both really nice and really pleasant and also very difficult to get started with. But I wanted more people to be able to do this. I wanted to like make it easier on the next person who comes along and says, I want to make a live coding environment using an obscure Lisp in the browser.
And so many people are in that position.
So I wrote a book about Janet because I think it's a really well thought out and really well considered language that I just matches my personal taste very well. And I found I really liked it a lot more than I was expecting to when I started using it. And I wanted it to have more exposure. So I wrote a book that no one's read about Janet. And it actually worked. Someone actually made a live music coding environment inspired by the live coding environment in the book and like based on the source code, forked it and made a live music environment called Train, Trane.
Is that named after Coltrane or like?
I kind of guessed that when I read it, but I don't know the actual etymology. And it's a delightful site. It has this very idiosyncratic UI that looks like a Windows command prompt. It's nice. It was nice that someone actually was like, yeah, I also want to build a weird art playground using this weird language.
So you've spent an enormous amount of time on lots of different kinds of personal projects. I'm curious to what degree that experience has changed how you think about programming in other contexts.
So I feel like everything that I have done for fun, I've ultimately ended up using somehow at work. And I think maybe part of that is because I've worked on a lot of different areas, so I like have more opportunities for this. But not that I would ever have expected this, and it's not the reason why I'm making goofy side projects or art projects, but I've always learned something, and then within like a year, somehow, unpredictably, something comes up such that I get to use the knowledge that I learned. And I think having exposure to a lot of different programming languages, I've always been interested in programming languages from a theoretical standpoint, and I think that thinking about how different languages solve problems helps immensely for modeling problems in any specific language. The experience of using Haskell for a couple years to build what I thought were trivial applications and building them in completely different ways because I'm dealing with immutable state for the first time and learning how to think differently about that I think that that's very mind expanding and has given me more tools to approach like modeling problems. Also, I don't know, still learning, obviously. I wouldn't say that I've gotten good because I've written a bunch of different side projects, but I have learned a lot of different ways to approach problems that have helped me out in real life.
Have you learned anything from Janet in particular?
Janet was my first experience with a language. I'm not a Lisp person, and I wasn't really looking for a Lisp language. Apart from this dabbling with Clojure earlier in my life, I never got into the macro system. I never really appreciated this aspect of Lisp. I kind of thought this was like a dumb, weird, I don't know, I don't really like it, and it seems weird. And with Janet, it was the first time that I had really used a language with a powerful macro system and really embraced that and tried to really learn it and understand how I could use it to write programs better. And I think it's very mind expanding to think about writing code that is executing at compile time, but is producing code that will execute at runtime. And this blend between the compile time and runtime environment. Janet, when you compile a program, it produces like an image, which is something that no language that I had used before Janet. I know that's like an old technique, and Smalltalks do this, and Lisps have done this forever. But Janet was my first experience to this type of programming where instead of compiling to a bunch of machine code that exists and is static, you're sort of building this full runtime state and then writing that down to disk. And then later, when you run your program, you're resuming from this like snapshot in time. And what this means is you can do compile time computation and produce a complex object graph at compile time, and then write it down and restore it later and keep going. I thought that was really mind expanding and a really powerful technique that I don't have a good way to apply to any other language because it kind of takes a lot of language buy-in to be able to serialize arbitrary program state to disk. And this isn't just values. This is like, I have a coroutine that is in the middle of executing, and I'm able to suspend that exactly as it is and write that to disk and then resume it later. You can serialize closures over the network and like send them to a remote process and then execute the closure. Having this live code that you can freeze and then restore later is kind of a mind-expanding thing.
I've always thought of this as like a terrifying feature of Smalltalk because the way Smalltalk people use it historically, at least the way I've understood it, is not just I write my program and then there's a kind of multi-stage process where it does some stuff and then you freeze it and then maybe you take that thing and ship it and then that's your final program as their development environment. So they just have this binary soup of artifacts that they've just made over time as they have been working. It's no longer a program that you can read, really. You know, there's some code and there's some data and it all just kind of lives together in this complicated soup. I don't know how to build careful, high-assurance software in that kind of mode.
Yeah, it kind of sounds crazy to me, and I haven't tried it. And you can do this in Janet as well. You can start running your program, you can modify it, and then you can at any point save it back to disk. You can like take a snapshot. But the way that I have used it, and I think Janet's a small enough language that I shouldn't say like idiomatic, but like the normal thing that you do is this really two-phase thing where you are running your program up to a point, and then you stop. And then you're always resuming the program from that exact same point. So all of your code, all of the things that you've written on disk, you can always sort of deterministically, as long as your compilation is deterministic, like get back to that state. The state of your image is a reflection of the code as you have written it, as you have it in source control. It's not this mutable target that you're interactively changing. It sounds very error-prone. I know that Smalltalk gives you like the history of every change that you've ever made so that you can like, you're not like totally hosed, but it still sounds wild to me. And I've never tried to program like that.
Yeah, I mean, I feel like it could be a good environment for playing around with data, but it doesn't feel to me like a great environment for building a very careful piece of software that you need to make sure is actually doing the right thing all the time.
I mean, beyond the image and the fact that you're like working on the same program interactively over a long period of time because you're able to serialize the entire state to disk, but a common way that you write Lisp programs is this interactive thing as well, where it's not maybe quite as long running, but you write code and then you evaluate chunks of your code at a time and you're like redefining your program at runtime.
Yeah, and I think multi-stage programming is a good and important thing. Among the various good ideas embedded in Lisp, the macro system and more generally this kind of notion of multi-stage programming is something that Lisps have done really well from a long time ago. And very few other language ecosystems have done a good job of it. There's the whole like OCaml, SML, Haskell world. And I think that's a world that's been really good at types and very mediocre at macros and multi-stage programming. And then the Lisp world is one that's been the reverse, very good at thinking about macro systems and how to use them effectively. And the type story being much weaker and more complicated and harder to use. you're talking about it's hard to use this in other contexts. We are actually like literally at the moment working on stuff to add some of this power to OCaml at the moment in a kind of more static and limited way, right? I think it sounds like the Janet story is like fairly flexible and arbitrary multi-stage programming. And we're looking more at stuff where you can do runtime code generation and maybe do runtime code generation at multiple spots in your program, but not quite the same thing as like stopping and freezing your whole program and restarting it again with all of the state there. But that itself, I think, is already very useful. And I think having an understanding of how to work in that environment, I think is a thing that's going to become more relevant as we get more of those language features landed. Okay, so anyway, that's like lessons learned by working on personal projects that you've been able to adopt more generally, or at least influence your thinking beyond there. How about the other direction? Are there things that you've learned from the way you've programmed here at Jane Street that's influenced what you do in your personal projects and what you've learned beyond that domain?
So Jane Street has this way of writing tests, this expect test workflow. Jane Street's not the only place that does this, but it was my first exposure to this. And I kind of just can't believe that it's not the industry standard thing that everyone is doing everywhere. It's so much better in so many ways that I kind of can't live without it.
It's also like the image-based programming thing in that at first it sounds like a really bad idea.
Yeah. A lot of people, when they hear about this, they sort of are objecting to it. So what this is specifically is I'm going to write a test, and it's going to do something, and it's going to produce some output. And I'm just going to save that output to the file. I write a test that edits itself. It's going to modify the test code itself to embed the output of some function or whatever into that test. And then I can sort of use this like an interactive REPL, where I write some code, I run it, and then I have the result in my file, in the exact same file that I wrote it. Like it has literally patched the file on disk. It's not like I'm running it in a REPL and I see some transient result. And then it's saved. And it's when I go back, if I run the test again, it'll tell me if it is different. So the way that I can use this to write code is like very similar to the way that I wrote code without any tests at all, which is I write some code and then I run it. And then I see if it did what I wanted. And if it did, great, I move on. And if it didn't, I go and I fix it until it is good. And then once I've done that, I sort of save it and mark it as, okay, that was the thing that I wanted. And I use this interactive workflow when I'm just developing code and exploring it because it's just this really great feedback loop for seeing results.
And maybe the most relatable analogy of this is it's kind of like a plain text Python notebook.
Yeah.
Python notebooks, you write some code, there's like a block that has the output of the code that you wrote, and then you kind of do that over and over again. Except in the Python notebook case, you have this sort of interesting property that there are no guarantees that the stuff that's in the notebook reflects what would happen if you reran the notebook from beginning to end. The experience of a notebook is this kind of choose your own adventure of which cell do I want to evaluate now, which is, I think, often important in the Python notebook world because various of the steps could be really slow. So you kind of want to make the choice of like which parts you want to actually redo. But with expect tests, the idea is we have a file with one of these tests. Every time you rerun the test, it just runs from beginning to end. It regenerates all of the output. It checks it's the same as it was last time. And if it's the same as it was last time, that's the test passing. And if it's different, that counts as a failure. And it rewrites it with the new data. And you can choose with the click of a button, do I want to adopt this new version of the output or do I want to keep with what was there before?
Yeah. And this sounds a little bit crazy. It sounds crazy in a lot of ways. Like the description that I gave initially is not the best way to write tests, just playing around in a REPL. Like you kind of want to be thoughtful about the exact things that you're testing. You want to test precise properties, but it is both a valuable workflow as you're writing code, but then you can also produce very high quality tests because you're not just writing a traditional test where you're writing some assertion about some property, which of course we do a lot and is a very useful tool to have, but you can write something that is more a general observation of my program state. Like I have some property, I want to observe it, and I want to know if this property is ever different. So we have some interesting examples of, I want to do a bunch of work and I'm producing a side project where I've used this, for example, is like a board game. Okay, a bunch of things happen. I have some state. Just print out the board game. And that's an expect test. Now I can see
I have done this too. This is like an excellent use case.
It's great. Not only are you going to know if you ever break your board, you're going to be able to see that, but it's useful when a bug happens, you kind of have this observation of your program state that helps you debug it. It's not just, some assertion failed, some test failed. It's like, some test failed, and also here is the state, and here's what the state was supposed to be, and you can sort of immediately be like, oh, okay, like I see how this happened. And this, of course, is still compatible with like traditional assertion-based testing. We still write property tests, but we use the same technique when we write property tests. such that you found a failing case. Okay, I'm going to go and edit the source code of your test to insert the failing case and remember it so that future randomized runs will make sure that they handle this interesting regression. It is this mechanism for writing tests that can modify themselves that is really useful for observing properties of your program, but then is also just a really good UI for writing all kinds of tests.
Another thing I like about it is I feel like it helps resolve what I think of as one of the fundamental trade-offs in building programming systems. I often think about two extremes of you write a traditional program in some text file versus you write some computation in Excel, right? And I think the good thing about the text file version is you get this very compact, easy to read version of the code. And the downside is you can't see what it's doing. You can't see the data as it flows through the program. And then in something like Excel, the data is really easy. It's just cells out there you can just inspect and understand what's going on. And any particular computation, you can just kind of poke at it and see where the data came from and what it's doing. But the program is smeared over the spreadsheet all over these cells. And it's very non-compact and very hard to read. And this lets you resolve this duality in that you both get the compact representation of the program and you can pick custom laying out of essentially program traces. So you can see and visualize aspects of the execution of the program. It's really cool for code review because when you make a change that's supposed to change the behavior, you get to read in the same commit both the change to the code and the delta to the program trace.
Yeah.
Which is not to say that the whole thing can't be abused. I think one of the reasons people think of this at first blush as kind of a bad idea is it just seems like you'll get a bunch of tests where people dump garbage and say, and now I've tested it. And that's a real problem.
It is, yeah.
People, in fact, do get this wrong. A really good expect test is where one has really thought carefully about what data do I actually want to visualize? How do I actually want to represent this? And kind of minify it so you don't have a bunch of distracting nonsense. And the end result is actually readable and worth reading.
Yeah, it's a real failure case to just say oh, okay, tell me if anything possibly changes. But you really need to be careful and diligent. But the work that you do, it's not just in order to write your tests better. The work that you do to visualize your state better also makes it easier to change your program over time. You get this virtuous feedback where you spend time building these test visualizers to make your tests clearer and easier, and then they also just make it easier to make changes. So it was the first time where I really felt okay, I'm writing tests for myself. It is actually just making my job easier. The more tests I write, the easier it is to build more and more complex, interesting software. And it doesn't feel like it's adding this cost where okay, now I gotta go write tests after. It's
oh, it's kind of fun.
Yeah, it is. And it just is the way that you interact with your program.
Right. In the same way that playing in a REPL or in a notebook is a fun way to knock around, writing expect tests is fun.
So if you want to use Janet, first thing I had to write, of course, was a complex macro that does this patching of the source code so that I have the same workflow in Janet because I'm spoiled and I can't write code without it anymore.
The history of expect tests is kind of interesting in that it's definitely not our idea. We stole it actually very concretely from Mercurial, which has this set of tests that they built internally, which are basically expect tests for bash, where you write some bash commands and you see the output and there's a little single unified file format. I think they called it their unified test because it unifies the output of the test and the code that generates it. And then somebody went off and built a tool called CRAM. I think hasn't been touched in several years, but it's another version of this idea, generalized beyond Mercurial. And then we built some version of it and did a lot of blogging about it because we thought it was kind of fun. And there's several Python versions of this that have been built. I think the idea didn't come from us, but I think we've been involved in the set of people slowly popularizing it and spreading it out in more cases. And it's kind of been nice to see it get out into the world.
Yeah. It's also something that Jane Street does that's a little bit idiosyncratic, but is unlike using OCaml or using Bonsai for everything, something that anyone could do. This is an idea that is completely language agnostic, and there are libraries for doing this in almost every language. And if there's not, you should write one because it's a very good workflow.
I have to say the tooling is frustratingly hard. Every now and then.
Yeah.
So I've now had the experience of teaching my kids how to program, which I guess you're not quite there yet.
Almost.
Give it a few years. And one of the frustrating things is how poor the testing frameworks are. You get something in class of write the following system, and they're often fairly hard assignments and they're hard to get right. And maybe you're doing it in languages like C and C++ where there's all sorts of weird cliffs you can fall over. And then just no good testing tools. And that's no way to live. And so I've looked around for good ways of doing things like expect tests for C programs and the landscape's not great there.
Yeah, Jane Street's OCaml tooling in Emacs around this you save the file and you immediately see a diff of all of your tests. And then there's like one button that lets you copy in the output to promote it to this is the good version. Like that tooling is actually really important to making this pleasant. So yeah, I've had to re-implement that, unfortunately.
Amazing. All right. Well, thank you so much for joining me. This was a lot of fun.
Thanks, Ron.
You'll find a complete transcript of the episode along with show notes and links at signalsandthreads.com. One thing I wanted to mention is that, as you may have noticed, the pace of releasing new episodes has slowed down a bit. Don't worry, we're not going anywhere. In fact, we've got a bunch of episodes planned that I'm really excited about. But things have been busy, and I do expect the pace to be a bit slower going forward. Anyway, thanks for joining us. See you next time.